Welcome, my dear students. In this video, I am going to discuss forecasting with auto series. Let me start with an example, and I call this example number 9. One of the most useful features of eViews is the ability to estimate and forecast from equations that are specified using expressions or auto series. Issues with auto series normally arise when the dependent variable is specified using an expression. In this section, we will illustrate through a number of examples how eViews performs forecasts in these cases. Let us suppose I am going to regress the log of payroll on a constant IP, ISM and T-bill 3M. These are the three exogenous and dependent variables, and then I also use a trend and the dummy variable where I drop the last month. And when I click this, I will write this expression in one line, and then I will click, and after clicking I get this equation, and this is the estimated equation in which the dependent variable is the log of payroll. This is constant, which is significant, and this is IP, which is also significant. ISM is also significant, and T-bill is also significant, and some dummies for some months are insignificant. If I want to forecast from this equation, I will click this, and after clicking this, I will get this, and here under series to forecast, either I can forecast payroll or I can forecast log of payroll, and there is no provision for dynamic forecast in this equation. So the only method available for this is static forecast, and here I will set the sample, and after that I will click OK, and when I click OK, I get this. Now the forecast output for both levels and log forecast are shown here. This one is a forecast of levels of the payroll, and this one is a forecast of the log of payroll. So they are more or less the same, not much difference. And similarly, we can just as easily estimate the first differences using auto series as well. And in that, I am regressing D payroll. D payroll means payroll is in first difference. C is the constant. ISM, T-bill, 3M. These are the independent variables, and this is the dummy variable in which the last month is dropped. And then when I click this, I will get the estimated equation, and after the estimated equation, on the equation toolbar, I will click on forecast, and then I get this window. So here we can either forecast payroll at level, or we can forecast payroll in difference form. So we can either do dynamic forecasting or static forecasting after setting sample, and then we will click OK. So after that, we see that these are the forecasted output for both the dynamic and static methods. We may note the forecast for both methods are the same. That is, for the dynamic and for the static methods, the forecast are the same. Since the equation is not truly dynamic, because the lagged dependent variable is not on the right hand side of the variable. So as we expect, static forecast and in 2013 month 4, whereas dynamic forecasts are provided for the entire forecast sample. The standard deviation differ, however. The dynamic forecast standard errors take into account the forecast uncertainty from the lagged values of the payroll series, whereas the static forecast does not, since it uses the actual values of the payroll series. Static and dynamic forecast will differ, however, when we include a lag dependent variable. Until now, we didn't include lag dependent variable. Now we will include lag dependent variable. So if you can, we will type in the command window first sample estimated, and then least square, and that is the difference payroll. That is my dependent variable, which is in the difference form, first difference form. This is constant, and this is the lagged value of the difference of payroll, and then ISM and T bill 3M, and then we have the dummy variable command by dropping the last month. And on the equation toolbar, when I click this, I will get the estimated equation, and then on the equation toolbar, I will click on the forecast, and then I get this window in which there is provision for dynamic forecasting and static forecasting, and we have the facility to either forecast of payroll at level or forecast of payroll at the difference. And then we will set the sample, and after that, when I click OK, I get these. Now if you compare the graph of the dynamic and static forecast here, both for the first differences and level, they differ because the dynamic forecast uses forecasted values of payroll, whereas the static forecast uses the actual values of the series. Standard errors for the dynamic forecast, which are not shown here, are also larger because they take into account the forecast uncertainty from the lagged value of the payroll. So in both of these graphs, this blue line shows dynamic equation forecasting, and this red line shows the static. Similarly, at levels, this red one is static forecasting, and this blue one is the dynamic forecasting. If the model includes a lagged dependent variable, it matters for forecasting purposes whether the dependent variable is an auto series or not. Let us re-estimate the previous equation when the dependent variable is not an auto series. And in this case, let me generate a series D payroll, which is the first difference of the payroll, and then I will regress. I will write this in one line and will click. So my command will be ls D payroll, constant D payroll in lag form, ISM T bill 3M, and then the dummy variable command with the drop last month, and I'll get the estimated equation. And on the equation toolbar, I will click on the forecast, and then I'll get this window. And again, it has a dynamic forecast and it has a static forecast method. And then I will set this sample, and I will click OK. And after that, I get these dynamic forecast and static forecast graphs. Now, the graphs of the dynamic forecast from equation 11 and 11a that I have saved are identical as shown here. However, the static forecast differ because equation 11a eViews is able to produce the one step ahead forecast for the one period only, that is 2009 month 1. This is because D payroll was derived from the D payroll over the estimation period ending in 2008 month 12. In contrast, in equation 11, eViews knows that D payroll is a transformation of payroll, so it uses actual values of payroll which are known up to 2013 month 3 to compute the static forecast. We can use more complicated expressions, and eViews will be able to forecast the underlying series if is able to normalize the dependent variable expression. And here is an example. This time I take the first difference of the log of payroll, and that I regress on constant, and then on the lagged value of the difference of the log of payroll, and ISM and T bill 3M, and then I use the dummy variable for the month and I drop the last, and then when I enter, I'll get the estimated equation, and then the estimated equation toolbar I will click on forecast, and after that I get this window, and again I can either make forecasting for payroll at level or for this, that is the auto series, that is the first difference of the log of payroll. And again I can use the method of dynamic forecasting or the method of static forecasting. And when I click OK, I get this. And if the dependent variable is an auto series derived from two or more series, eViews will offer to provide forecasts of the level of the first series. And here is an example. That is the sum of payroll and ISM. I have summed up two variables, and I regress this on constant and trend and the lagged value of the ASM. And then this time I can either forecast payroll only or the sum of forecast and ISM. And this time the eViews doesn't provide the um, method of dynamic forecasting, only static forecast method is available. And after setting the sample, I will click OK, and then I will get the forecast. If eViews is unable to normalize the expression for the dependent variable, it will offer to forecast the entire expression and not the underlying series. And here is an example. This time I regress the log of payroll plus 1 divided by payroll on C and trend and payroll with lagged first leg, and then I have just static forecast, and I will set the sample, and if I click OK, then I will get the forecast values. Ladies and gentlemen, I thank you very much for your attention. If you haven't yet subscribed to the channel, kindly do so, and do not forget to click on the bell icon so that you can get notification about my coming videos that I'll upload for you. Thank you very much for watching my channel and videos. Kindly do share the channel and videos with your friends, with your colleagues, and with your students. Thank you, and see you in another video.